Assalamu alaikum everyone. This is Abdul Qadir Goni and I welcome you all in my classroom, Goni's classroom. Today we are going to discuss about resolving vectors, how to find out the components of a vector. Okay, in the previous video we discussed about adding vectors, and in this video this is continued from that video, and in this video I'm going to discuss how to resolve vectors. That means how to find out the components of a vector. For example, okay, and another thing I want to discuss with you, this topic will be discussed in a bilingual form, that is I'll be speaking in two languages, English and Bengali. Okay, ধরো যদি একটা আমরা আগের যে ভিডিওতে দেখেছিলাম যে যদি এই ডিরেকশন বরাবর একটা ভেক্টর 3, সাপোজ এটা যদি ফোর্সও হয় 3 নিউটন কাজ করে, and another vector perpendicular to this 4 নিউটন কাজ করে, তাহলে দুটো ভেক্টর যদি পারপেন্ডিকুলারলি কাজ করছিল তখন আমরা তাদের রেজাল্টেন্ট যে ভেক্টরটা দেখেছিলাম সেই রেজাল্টেন্ট ভেক্টর আমরা দেখেছিলাম। রেজাল্টেন্ট ভেক্টর পেয়েছিলাম আমরা this one, and we found this as 5 Newton, and the angle we calculated in the previous video, this was 37 degree. Okay, and now we are going backwards. Okay, suppose this is the vector given and this is u, which is acting with this direction with an angle alpha. Okay, then the two components of this vector, those are perpendicular to each other, will be the horizontal. Okay, if this is a horizontal line, we can consider this as a horizontal component, or in this direction the component of u will be u cos alpha, and the component, another component perpendicular to this component, will be u sin alpha. Okay, these two components, u sin alpha and u cos alpha, are perpendicular to each other and also independent to each other. What does that mean, independent to each other? That means that neither one affects the other vector. Okay, u sin alpha doesn't affect u cos alpha, or u cos alpha doesn't affect u sin alpha. That's why we can say that u sin alpha and u cos alpha, these two components are perpendicular and independent to each other. So remember, when two components are, or when two vectors are perpendicular to each other, they will be independent to each other. Okay, and if we solve this problem in this way, okay, suppose u is 5. Okay, if u is 5 Newton, then this component u cos alpha and alpha, if alpha is 37 degree, and this component will be 5 cos 37, and you'll find that this will be 4 Newton. Okay, and this component will be u sin alpha, that is 5 sin 37, and you'll get this 3 Newton. Okay, these are the components, and if u, the vector u, acts at an angle alpha with this direction, if we consider it as a vertical direction alpha, then the vertical component will be u cos alpha, and the another component perpendicular to the vertical one will be u sin alpha. Okay, তো মনে রাখতে হবে অ্যাঙ্গেলটা যে ডিরেকশনের সাথে তৈরি ওই ডিরেকশনের কম্পোনেন্টটা হবে হচ্ছে u cos alpha, আর তার সাথে পারপেন্ডিকুলার ডিরেকশনের কম্পোনেন্টটা হবে হচ্ছে u sin alpha. ওকে, এবার আমরা যদি ভেক্টরটাকে এইভাবে কনসিডার করি, মনে করো হচ্ছে u এই ডিরেকশনের সাথে আলফা অ্যাঙ্গেল প্রডিউস করছে, তাহলে আমরা যেটা লিখতে পারি this component will be u cos alpha. Remember, closer one is the cos. Closer one is the cos, and this component will be u sin alpha. Okay. So this is the way how we can resolve a vector and how we can find out the components of a vector. And again, I'm saying that you must remember that these two components are perpendicular to each other. That's why they are independent to each other. One doesn't affect the other. Okay. Now, আমরা এবার একটা এক্সাম্পল দেখি। এক্সাম্পলটা হচ্ছে এরকম, মনে করো এই একটা বক্স, এই বক্সটাকে someone pulling with a force of 5 Newton, and the box is moving horizontally. The box is moving horizontally. This is the initial position, the final position of the box, and the box has moved, suppose 5 meter. Okay. In this case, if the person is pulling the box with an angle alpha to the horizontal, then the horizontal component of this force we know will be 5 cos, and alpha is 37 degree, 5 cos 37, and we'll get this 4 Newton. Okay. And the perpendicular component of this force will be 5 sin 37, and that will be 3 Newton. And you can see that the box is moving horizontally. Okay. The 5 sin 37, that is a vertical component of the force, is not responsible for the box moving in horizontal direction, but the force or the component of the force that is responsible for moving the box horizontally is 5 cos 37, that is 4 Newton. And if you want to work out the work done on the box, you must use the formula. We know that work done is equal to force multiplied by the distance moved in the direction of force. Okay. In this example, আমরা একটা ভুল করতে পারি, সেটা হচ্ছে যে আমরা হয়তোবা এখানে যদি সাপোজ আমার অ্যাপ্লাইড ফোর্স 5 নিউটন বসাই এবং ডিসপ্লেসমেন্ট 5 বসাই, তাহলে আসবে হচ্ছে 25 জুল, বাট দিস ইজ অ্যাবসলিউটলি রং। ওয়াই? বিকজ এই 5 মিটার যে ডিসপ্লেসমেন্ট হয়েছে, আমাকে এখানে এই ফোর্সের যে ফর্মুলা, সেই ফর্মুলার মধ্যে মনে রাখতে হবে work done is equal to force into distance moved in the direction of force. Okay, since the box has moved in this direction horizontally, you have to consider the horizontal component of the force, and that is 5 cos 37 4 Newton. So the work done will be, in this case, since the force or the component of force acting in the direction of the displacement 5 meter is not 5 Newton, that is actually 4 Newton. Okay, then the work done will be 20 joule. Okay, now we are considering another example. Okay, now we are finding out component of weight along a sloping surface. Okay, the component of weight along a sloping surface. Okay, suppose this is horizontal line and this is a slope with an angle theta. Okay, with an angle theta to the horizontal, and a box weighing W. The box having a weight W is placed on the slope. Okay, and like this. Okay, if I put this marker on this slope, it will roll across the slope. Okay, look, when I put this on the sloping ramp or sloping surface, it rolls across the slope. And if I ask you, why does the marker roll across the slope. You'll say, someone will say that due to the weight. Actually, not for the weight. The box is not rolling across in this case, the box is not sliding across the lamp due to the weight. Actually, it is sliding or moving across the slope due to the component of the weight along the slope, and the component of the weight along the slope will be W cos theta. Okay, and the another component of the weight that is perpendicular to this one will be W this component will be W sin theta, and this component will be W cos theta. Okay, now we are going to derive it, how this comes. Okay, first consider the previous one when we were discussing about the components. Suppose this is a vector u. This is a vector u that is acting with an angle alpha with this direction. Then we can write that the component of u in this direction will be u cos alpha, and the other component perpendicular to that one will be u sin alpha. Okay, and let me tilt it. Okay, suppose u is acting in this direction, and this is a direction, and with this direction the angle between this direction u is alpha. Then we can write this component as u cos alpha, and perpendicular to this component, other component will be u sin alpha. Okay, and if we consider u as W weight, then this component will be W cos alpha, and this one will be W sin alpha. Okay, এবার আমরা এই সিচুয়েশন যদি আমরা দেখি, তাহলে আমরা এই ডায়াগ্রামটা সিম্পলিফাই করি। দেখো, এটা যদি থিটা হয় তাহলে this one will be 90 degree since weight is acting vertically downwards, and this angle will be 90 minus theta. Again, if I simplify this is weight, this is the direction of the slope. Okay, and this is perpendicular, so the component of weight, and if this is theta, this will be 90 minus theta. Okay, তাহলে আমরা যেটা বলতে পারি, weight এর এই দিক বরাবর যে component along the surface or along the slope will be W cos 90 minus theta, and the other component perpendicular with this, that will be W sin 90 minus theta. Okay, so W cos 90 minus theta. Okay, this W cos 90 minus theta, using trigonometry we can write W cos 90 minus theta as W sin theta, and this one W sin 90 minus theta we can write W cos theta. Okay, and if we substitute W as mg, mass into gravitational field strength, we can write mg sin theta, and this will be mg cos theta. Okay, here we come, W sin theta or mg sin theta along the slope W sin theta or mg sin theta. Okay, and the other component along the slope, and this one is the other component that is perpendicular to the slope, that is W cos theta or mg cos theta. Okay, and now we understand that the box is moving along the slope not because of the weight. It is moving or sliding along the slope because of W sine theta or mg sine theta. And what about this component? Okay, this component W cos theta or mg cos theta actually is balanced by the normal reaction force. Okay, W cos theta or mg cos theta, that is the component perpendicular to the slope, is balanced by the normal reaction force, and this is the component W sine theta or mg sine theta is responsible for the box moving along the slope. Now, if we consider the slope as smooth, frictionless, when it is mentioned in the paper that the box is moving along a smooth slope or frictionless slope, this mg sine theta is the unbalanced force acting on the box, causing the box to accelerate down the slope. Okay, so now if we, again I'm saying, if we consider the slope being frictionless or smooth, we can write that the unbalanced force F is actually mg sine theta. Okay, and we know that unbalanced force is equal to, if the box has a mass of m, ma is equal to mg sine theta. Cancelling m from both directions, we find that a is equal to g sine theta. This is taught in your mechanics M1. The acceleration down the slope is g sine theta. You can use this formula directly while calculating your problem in your exam. Okay, the acceleration of the slope along the surface A is equal to g sine theta if, I'm saying again, if the surface is considered to be frictionless or smooth. Okay, so these two are the components of weight, and I hope you understand this video and you can use this in your exam. Okay, see you guys, and see you with with the next video, and next video will be done on projectile. Before discussing or going to that topic, you must understand how to add vectors and how to resolve vectors to find out the components. Okay, Allah Hafiz.